Okay, today I thought we will do oil tanker, but I see in the title Ro-Ro ships. So, let us do Ro-Ro ships. Next time we will take up oil tanker. Okay. So, what is this Ro-Ro? Any idea? Roll on, roll off, right. So, roll on, roll off. Again, that same concept came because automobile is one of the commodity which is very highly traded, right. There are countries which are big producers of these automobile cars and some countries big consumer of automobile cars, like Japan is a big producer and US is a big consumer. So, that is how all this game started. That means they are producing at their own land and transporting, exporting to US, right. That is how it all started. So, again here the cargo is somewhat different, like we have seen cargoes, general cargo, liquid cargo, bulk cargo, containerized cargo. This is a automobile cargo, a cargo which is by itself is mobile, it can move of its own, right. So, that very aspect, that means the cargo itself can move. So, that aspect has been taken advantage of in designing these vessels. Why? Again that same aspect of loading, unloading, right. So, here the whole concept is that the vessels, these cars, the automobiles or the cargo will roll on the vessel will sail with the cars and at the port of destination it will roll off, right. That is how roll on, roll off. So, what we need for this? That means we need proper stowage spaces for the cars. We have seen what kind of stowage, cargo stowage space is required for general cargo ships, for bulk carrier, right, for container and now for the cars. We will have to, these vessels are dedicated for carrying car only, Ro-Ro vessels. Well, car means car, automobiles, right. So, what do you think would be from your common sense that what would be the configuration of these vessels? Multi-deck, straightaway multi-deck, because here you do not need a hold as such, because here the cars cannot be really stored in bulk. You will have to store them very nicely one after another. And here we are seeing that we take help of its own propulsion power, means own engine to drive in, instead of putting them through the cargo hatch. So, obviously, hatch opening, there is no concept of hatch opening, we do not need hatch opening, right. So, we will have some other arrangement through which the cars will enter, right. So, first and foremost is it is a multi-deck vessel. Now, before we go for the multi-deck, we draw the basic minimum which is common for all vessels, that means the outside hull and the double bottom, right. Whenever you do a midship section, so immediately first draw this, the outside hull and the double bottom. So, you can immediately do the necessary decoration in the double bottom, right. Like this. So, this way you indicate that it has a double bottom with and you are drawing a section at a floor, at a plate floor, that is enough. So, it gives an idea. Your one side girder I have just also added here, right. So, this is done. Next thing will come from the functional requirement, that it is a multi-decker vessel. So, it will have several decks. Difference between say general cargo ship is also can be a multi-decker vessel. Generally, it has only one lower deck. I can also have two lower decks, but generally not more than that, but it will be many more. Here we have drawn at least 1, 2, 3 decks below main deck, right. It can be more depending on how much depth you have and how much minimum clearance is needed between two decks, right. Thereby you can have this. So, straightaway multi decks, and obviously since this vessels also will be, well, the primary strength requirement is longitudinal strength. Primary requirement is longitudinal strength. So, immediately I can have all longitudinally stiffened, all the decks longitudinally stiffened. So, longitudinal stiffening arrangement for all decks, right. And since it is a closed decker ship, means is a kind of a closed construction, that means there is no hatch opening. So, obviously, torsional strength is not a issue, is not a problem, right. So, what you need is proper strength, longitudinal strength, and as well as transverse strength. Now, transverse strength is also very well achieved because of so many decks are already there. So, those decks are continuous from port side shell to the starboard side shell, it is continuous. So, so many of them, the whole structure becomes really very strong. So, strength wise it is not a big problem, right. Decks are to be made strengthened enough, because you will have it will sustain all the loads, the wheeled vehicles will be there, right. Anyway, whatever way you draw, I mean some schematically, the vehicles will be there one after another, right. So, that is how its main stiffening arrangement will be longitudinal stiffening for the all decks. Again, for the same logic of general cargo ship, side shell will be transversely stiffened, right. That means, in side shell we will use transverse stiffeners, whereas in the decks will be longitudinally stiffened, right. That is how. So, these all will be bracketed. These are all bracketed, the side shell stiffeners, right. And then again the decks are longitudinally stiffened, that means you will have to have those transverses at intervals, right. They come, right, the same to provide support for those longitudinals, that means transverses will be there, right, at third or fourth frame spaces like this. All the, obviously in all the decks it will be there, right. And naturally, once again I am just repeating that these transverses will be there in the same plane. You will have wave frame on the side, frames of higher scantling, stiffness of higher scantling, right. They will be suitably bracketed, connected, and also in the same plane you will have the plate floor like we have drawn. In between, these transverses will not be there, these wave frames will not be there, side shell wave frames, plate floors also will not be there, there will be bracket floor, right, that concept of bracket floor. So, what do you see? That every third or fourth frame space you have a kind of a ring like structure. The ring is, you have the deck transverse, this is what is your deck transverse, right. In the same plane you get the wave frame of the side shell, right. As you come down you have the plate floor, go to the starboard side, again the plate floor continues, wave frame, deck transverse. So, as if it is a ring, that ring like structure will be repeated every third or fourth frame space, or as per the classification guidelines. Okay. So, basically that this ring like structure is providing support to the longitudinal members both at the decks as well as at the double bottom, right. and also these ring like structures are providing the necessary transverse strength. So, these are the members which provide for transverse strength, means members, stiffeners in the transverse plane, they are providing for transverse strength of the structure. What else provides transverse strength? Which member? The deck itself, well, of course, because it is a continuous plate, port starboard, also it will provide, but more importantly, transverse bulkhead, transverse watertight bulkhead. It provides strength only in the transverse plane. It does not provide in the longitudinal strength, right. That is one of the member which is important towards transverse strength. And similarly for longitudinal strength, the longitudinal members, all the longitudinals, be it deck longitudinal, be it inner bottom longitudinal, be it bottom shell longitudinal, side shell longitudinal, whatever longitudinals, longitudinal stiffeners, central line bulkhead in case of oil tanker, because otherwise you do not have central line bulkhead. That is a specific case in case of oil tanker, it does provide longitudinal strength. But of course, there its purpose is different, that is not been put to provide give me longitudinal strength, it is provided for reducing free surface area. At the same time, it is contributing towards longitudinal strength. So, the scantlings of other longitudinal members can be reduced, right. So, in general, all longitudinal stiffeners, central line girders, hatch side girders, side girders in the double bottom, they are all stiffening members contributing towards longitudinal strength. And obviously, side shell, bottom shell, deck, they contribute to both transverse and longitudinal strength as such. So, that is how we see that this is the general layout or the structural layout of a ro-ro ship. So, what basically we are seeing is once again the same thing, that you need to have a structure which is strengthened in all these aspects: longitudinal, transverse, torsional, local. These are the 4 strength requirement to be satisfied, such that the ship can sustain the service loads, right. So, to do that, it is preferable to adopt longitudinal framing system, because it gives you better buckling strength, and then to satisfy your transverse strength, you have to have adequate transverse stiffening members, which we are again getting from this transverses, wave frames, floors, bulkheads, transverse bulkheads, right.
So, how does the loading and unloading take place?
Oh yeah,
we will
we'll come to that. First, just taking a look at the midship section, how a section at the midship looks like. So, that is how the this is well, the arrangement is done. Just to sake of completeness, some of these scallops we are drawing, that means there will be as usual those scallops, right. And it is not only scallop, the detail we have shown you how they are connected, because at the time of fabrication you need that cut opening to fit it, that means to have the what you call the longitudinal passing through that. But yeah, you have to provide suitable welding of the web and add a additional collar plate, so that you get a proper clamping of that, because we are saying the span is from one support point to the other support point. So, to provide for proper support. So, detail of that we have already seen. So, that is what is the midship section, and as far as the vessel is concerned and its loading and unloading facilities are something like this. Here there are certain aspects are there. Well, so we have these 2 bulkheads which are referred to as collision bulkheads, or referred to as forward peak bulkhead or forward collision bulkhead, up peak bulkhead or up collision bulkhead. Anyway, forepeak, up peak, right? Two bulkheads are there, and you have this double bottom, and then we have several decks. I have drawn how many? 1, 2, 3, 4. Okay. This is one line, is the water line I have drawn. Anyway, say there are 4 decks. I mean 3 under decks, right? 1 double bottom, right? So that means this is my here the cars are not being carried in the on the what do you call on the weather deck, the exposed deck, right? They are all carried below the main deck. So you'll have the superstructure like this, right? And below the main deck, all cars are carried. So what is the entry point, right? So entry generally is from a opening like this, opening at the side. So there is a opening here. Opening means a ramp will be there. The ramp will open up. That means it is something. So this is my section. So this is the section at this ramp level, right? So here you have as if I mean this ramp level will be, say it is docked against a berth, right? So the ramp will open up. It opens up like this. So a car can come straightaway drive inside, right? The car can straightaway drive inside through this ramp. So it goes in. Now it travels down, and then you have another ramp here. Ramp is a sloping this thing like we have, well, you may have seen. Yeah, so only thing at the top, just below the main deck, I mean the weather deck, they are above the water line. The purpose of drawing this water line is, that means one of the deck or where the ramp is opening up, it has to be above the load water line. You cannot keep the ramp immersed in water. Though this ramp, when all cars are loaded, it will close up. It will have a properly watertight closing. But if the part of it remains under water continuously immersed, so it may start leaking. So you cannot afford to have that. It is above that. That means one of the deck has to be above the load water line. Then only you can have a ramp there, right? Well, so it goes like this. Then again you have another ramp here and a final ramp there. So a car can travel down right, entering here, it can park. The first car will park itself here at this corner, isn't it? And then gradually go on filling up, because if you park the car right here, then naturally you cannot go. So while you will fill up, and the drivers will, of course, will come out. There can be, if the vessel is like this, then the drivers will leave the car and leave the ship. A fresh set of driver will come and drive the cars out. If drivers are to stay on board, then they cannot stay in the car. So then again it becomes a different issue. It becomes almost like a passenger vessel. So that is not very feasible, because a car carrier capacity could be 2000 car. So if 2000 drivers you want to accommodate, that becomes a problem, right? So generally drivers are not staying. That means that they leave the car and go out. So that is again another requirement. That means how the driver will go out. He'll have to simply walk down, right, and come out. Walking down means what? He is walking down through this space. There can be some staircase, some provision, but important is in this enclosed environment and you are driving the car in enclosed environment, whatever be the your Bharat norms or Euro norms, some emission is there. So, very stringent requirement of ventilation is a must, because otherwise there can be a CO accumulation, and that may lead to, when the driver comes down to the last car to board that, he may go unconscious, right. So, one of the typical requirement of this type of vessel, that in the cargo hold needs a very stringent ventilation requirement is there for the cargo hold. Other cargo holds we have seen for other ships, that aspect is not so important. So, here is the additional thing. Well, so that is how the cars are loaded. It is generally side ramp, or at times it also has a arrangement like this. Arrangement like this, that means this forward part opens up. This is not very correctly drawn. What happens is the forward part opens up, it almost like a opening the mouth. The forward bow lifts up, so you have an entry. So, from forward you can enter. That is, of course, that becomes more difficult construction wise. It's preferable to have the side ramp. So, the advantage is generally ships are berthed sidewise and the side ramp opens, you get in. It's easy to say it that way, but imagine a situation as the cars are getting unloaded, it is floating up, right. So, what is happening to this ramp? It will start becoming stiffer and stiffer. So, all those problems have to be solved. Same thing when you start, when the vessel is empty and start putting in the cars, it will gradually comes down. So, when the first car goes, it will be very stiff maybe. So, you will have to have proper ballasting and deballasting arrangement, because that stiffness could be very severe, you won't be able to drive up, it is not feasible, because there is a draft change could be in meters, not only not centimeters, in several meters, and the ramp you cannot make 100-meter long, so that it takes care of that angle, no. So, ballasting and deballasting while loading of the cargo, you will have to have a, that means proper, like ballast spaces in other vessels are needed also, but they are needed primarily for the purpose of adjusting the loading conditions, and for all practical purpose in a general cargo ship or in a container ship or in a bulk carrier, your ballasting, deballasting provisions are to be kept, but they are not that much needed. For a oil tanker it is needed, why? Because the return voyage is empty, oil tanker always return voyage empty. So, when you come back empty, your propeller will stick out, isn't it? Because it will have hardly any weight, so it will float at a very low draft. If the propeller blade sticks out, it won't have proper efficiency. So, intentionally sink it further, you will have to put in ballast water. So, there, and in this case, this is the specific thing to make adjustment of the ramp. So, you will have to take in ballast water, start loading the cars and slowly keep deballasting, balance it, so that the ramp angle more or less remains within a limit. So, that is an additional requirement. Well, so, and as far as the entry car loading is concerned, the side ramps, it can be in both the side, port and starboard. So, whichever side it parks or it berths the vessel, it can be entered. Some they have forward loading also, this forward ramp, but preferable is in the side. Whatever, whether it is a side ramp or forward ramp, they should have proper so called telltale arrangement. You know, telltale, this term is used. Telltale arrangement means some remote sensing that the door is properly closed. The ramp door has been closed, because if you recall, maybe some 5-6 years back probably, or maybe it is already a little more, one such ro-ro ship sank in the harbor itself. It was fully loaded and supposed to sail the next morning, and they find, I mean, it's already half immersed. Simple reason what happened, I mean, for stupid reason. That means the cars were loaded, the ramp was not very properly closed. It was not closed properly, or whatever. I mean, the water tightness was not there, though it is supposed to be above water. But what happened, probably that was a little stormy night, so a lot of waves in the harbor even. So water started getting in. A good part of the ramp remained open, so that with every wave splashing on the hull, some water is going in. And for any ship, the most dangerous thing is taking in water is the most dangerous thing, because it takes in water means it becomes more prone to take more water, because taking in water means sinking, also generating some free surface somewhere, so stability may get affected. So it takes in means it will take more water, means it's doomed basically. So that's what happened and sank. In all probability, this there was no mechanism of checking from wheelhouse whether the door was properly closed or not, though these are very simple device or whatever. So now this is a must, that you will have to have a telltale arrangement and all that to check that it is properly locked and I mean watertight closed, otherwise there can be catastrophic damage. So that is what it is, and there is another aspect in it. Can you tell me, can you see from this also say that how it appears different from other vessels? Because I had been telling you that structural arrangement is done to well, based on, I mean, there are two aspects to be satisfied. Obviously, one is the structural soundness, strength requirement, etc. Another is functional requirement. These two are to be properly balanced. And obviously, on the background or the secondary comes is you have to keep in mind the production point of view. The arrangement should be such that I can produce it easily. Arrangement should be such that it can be better maintained. So those things are also there. But as of now, at this moment, we are primarily bothered with functional requirement and structural soundness, strength requirement. So here, another typical functional requirement is unobstructed movement of the cargo.
Bulkhead.
Yeah, bulkhead, transverse bulkhead I have not drawn. Any vessel you may have observed, whenever I draw a profile, the first thing, like when I was telling, whenever you draw a midship section, you draw the outer hull and draw the double bottom, because that is more or less a must. If a bulk carrier, okay, double bottom is little different. It's shorter maybe, because other part becomes bottoming tank, but this remains, right. Similarly, whenever you do a profile, you draw the profile, the main deck, and immediately put the bulkheads and a double bottom. This is the basic minimum. But here the double bottom I have given, but bulkhead I have not drawn yet. So this is one aspect. Like from functional requirement, container ship, we have seen the main deck is totally open, virtually totally open, right? Because so that proper loading and unloading for my efficient loading and unloading. Here for efficient loading and unloading, I cannot have any obstruction in between. So then what happens? Then it becomes a very dangerous vessel, and that's what happened. That vessel which sank is takes in water, means water goes, it fills up the entire vessel. There is no, if the bulkheads are there, then what would have happened? That only one compartment is flooded, and well, the vessels are designed keeping in mind that, well, if it is there is something called compartment standard, right? This term you have heard anywhere? Not yet, probably. One compartment standard or two compartment standard or three compartment standard. What does this mean? This means
Even after 2 are filled, it won't.
adjacent compartments, not one in the forward, one in the aft. That means, if two adjacent compartments are filled up with water, that means totally accessible to water. What does that mean? That means it is no more contributing towards buoyancy, right. So, then still if it is a two compartment standard, then two adjacent compartment getting fully flooded, the vessel main deck will not go below water. Not only main deck, theoretically there is a well, let me, when we are talking about it, it's better to. So, this is my main deck. If suppose, say I am purposely drawing very closely spaced as if bulkheads, and let us assume that these two holes have got damaged. So, what will happen? Your water line, the vessel will trim like this. The vessel will trim like this, isn't it? This is one thing very interesting in naval architecture. You will see that we trim the water plane instead of the vessel. We say the vessel is heeling, actually vessel we keep upright, and the water plane we put it in angle. Anyway, that's, it's all relative, and that's easier way that is done. So what is happening? The vessel is essentially trimming by forward, because these two compartments are no more contributing towards buoyancy. Instead, it is behaving as if it is adding weight to the vessel, right, in the forend. So, more weight in the forend means forend sinks further. So, that is how we have two methods of calculating this. One is called lost buoyancy method, another is called added weight method of calculating for what will happen in flooded condition, what will happen, what will be the damage stability condition, right, all those things you will do. So, this, the two compartments are damaged may mean either it is not contributing to buoyancy. So, if you go by that route, I call it a method of lost buoyancy, or if I go by the other route, that I consider them to be added weight to the ship. So, it is sinking. So, that is added weight method. Anyway, so it will float like this, and this water line should be, not only that it should immerse the deck, not only that,
Propeller should also be on.
no, propeller, well, can't be helped, whatever happens. Propeller, at the, when a ship has got damaged, then you don't, you bother about the safety of life, right, such that life is not at stake. So, it is said that if it is a two compartment vessel, then the vessel will heel, trim, everything will happen, but the final water line will remain tangential to a imaginary line called margin line. This is my margin line. What is that margin line? A imaginary line below the main deck line at side, below the main deck line at side. How much below? Well, I do not remember that all those things you will learn in your probably safety and stability class, but something below. That is why the name is margin. That means still that much of margin of safety you are having, because the moment deck gets immersed, again it becomes very much vulnerable, because deck is immersed means there can be some excess manhole on the deck which is more or less flush. There can be some or you do not know how much part of the deck is getting immersed, there is a hatch opening, or say here, well, you have the forecastle like this, right? Here the chain locker opening is there. So if the deck is immersed, water will start getting in through different, there can be some leakage points. Worst is the hatch combing. You have those hatch combing that has a minimum mandatory height of 600 millimeter. There may be a case that through the hatch, though it is hatch cover is there, but the part of the hatch cover is getting immersed, water may leak in. In any case, you are not taking any chance. That means water line, that means deck should remain dry. That is the idea. So margin line, it should remain tangential to the margin line. That is the thing. So that is what is 2 compartment standard. If 3 compartment gets flooded, well, and also it goes not beyond the margin line, it is 3 compartment standard. That is what. So that is how safety. Now in case of ro-ro ship, if any damage takes place here, the entire vessel gets flooded. So there is, you do not have any safety margin, right? So what to do? Now, well, till previously it used to be like this. That means only subdivision was in the double bottom. That means if the double bottom is ruptured, then well, the flooding is controlled, it remains confined, but not above. Any damage above, the vessel gets flooded, right? Possibly that vessel which sank, I forget, that is the whole problem. The name also I have forgotten, the vessel that did not have any bulkhead, I believe. But now it has become, wow, I think so mandatory, I am not very sure, but I believe mandatory to have bulkheads. You will have to have bulkheads. You will have big watertight doors. So life has become difficult, simple as that. Life, I mean, it was very convenient for loading and unloading, but now you will have to go on. There will be huge doors here in each in each deck, hydraulically operated doors, because otherwise manually probably cannot handle. So things have become more complicated for essentially safety. Safety of whom? Not actually for cargo. What is that? You have heard something? Safety of life at sea, yes. So SOLAS, from that it's called SOLAS. There is a SOLAS conventions, I mean they have every year or something like that. Safety of life at sea, that is what is important. So all these are basically, all these evolutions are basically for, first it started through SOLAS, means safety of life at sea, and after that another aspect started that has become important. What is that? Think. What is next more important? So what is that? Environment, right? So what is that from? Marine pollution. So that has taken this form, MARPOL convention. They are the 2 important conventions. MARPOL convention, marine pollution. So from this marine pollution, actually you have changes in design of oil tankers, right? There you will have to have cellular, we are talking about cellular construction yesterday. First it started with, it should have a double, we will talk about oil tanker, then we will see. So there the marine pollution, this MARPOL convention has made a whole lot of changes in the design of oil tankers, right? And then even ballast water management has come now in effect.
So here can't we seal the different flows?
No, the thing is like this. I mean, what the safety aspect was in this fashion, that what is happening either you will have to seal. By sealing you mean that entire deck space, that if it gets flooded, the one deck space gets flooded. That means this ramp, this horizontal, there you will have to have mechanism of having a hatch cover or something and close it. Feasible. But there what happens, there will be a parallel sinkage, because you are not sure if the if it is in one zone a defect is taking place or a damage, then well, this much is getting flooded. So that that remains to be seen, that how much parallel sinkage it will give. And then what happens, you are closing this, but these are, well, again the same issue here also with the bulkhead door closing, that they will be exposed to water. So there can be leakage, but once accident has taken place means it will try to go to the nearest port immediately. That is always there. So that could be one way. But
in case of an accident, it rips through two.
Yeah. Actually, what happens is here what happens, that this space will be, the volume is much bigger than one hold in the transverse plane, right? That is one aspect. Other aspect is that well, by providing bulkheads, I am not only making them safer, but also from the strength point of view, etc. also it is helping the transverse strength, though it gives me good transverse strength in this arrangement. But anyway, probably that is one of the aspect that it eventually came to, that you divided in transverse bulkheads. One of the reason could be that the volume occupied by one hold, so called hold between two bulkheads, right, for one damage, right, that will be less compared to the whole deck space from the forward end to the aft. That could be a reason. So that is how what we have now is the bulkhead with big openings with suitable means of closing that is needed. That is how this well, it has been taken care of. So that is what is the ro-ro ship. Well, another specific aspect of ro-ro ship is, like in bulk carrier, there is as such no concept of securing the cargo. If you see in bulk carrier, it's only load the cargo and at destination you unload it. At best, there are something called, at best, what is done is you have the, we are just little bit going back to the case of bulk carrier. Whenever you draw, try to be as much possible so called proportionate and maintaining the basic things. Basic things means generally they are in one line, this plate and this plate, right, they are in one line. Anyway, so in this bulk carrier, what happens, this is the basic configuration of the hull. Now you have the cargo. So it may be the case that the full space is not, the hold is not fully loaded. You are carrying, say, wheat, and you meet a stormy weather, the vessel is rolling. So there can be a possibility of little bit of cargo shifting, right? Yeah, cargo shifting is possible. So if the cargo shifts too much on the port side, then again when it is oscillating back, not necessarily the whole cargo will come back. So it may remain in a heeled condition, right? So what to do against that? So what is done is, not much can be done. There is something called some boards are put inside, just loosely they are put inside. They are referred to as shifting boards. Shifting boards, the name of those boards, it's only it somewhat prevents movement of that cargo, easy movement of the cargo, you know. So, thereby you are somewhat obstructing the movement of that cargo, because that is needed, otherwise it will keep remain in the heeled condition, then your maneuvering will become difficult, the vessel maneuvering problem. Similarly, in the ro-ro ship, there is another aspect that here the cargo, that means those vehicles, they will have to have a mechanism of locking the wheels, because otherwise you cannot put a chain and lock the car, because there is another aspect, the car you cannot damage it, because their brand new cars are going, they will go in the market, and if it is dented, scratched, damaged, nobody will buy. So, there is a mechanism of it will drive in and the wheel locks will come up and jam the wheels, all the 4 wheels. So, through that it will hold. So, those are additional features needed in case of in these vessels. Similarly, in tank container ships, yesterday we had been talking about, there is, I mean, this is for your information, right? Like you have the containers whichever they are in the hold, they are okay, things are fine there as such, because they are self-locking type. One container, you put another container on top of it, they lock themselves. I mean, there is some opening are there where a pin goes in, right, self-locking, and it is stacked in the hold, one after another, they are closely spaced. There is a I mean all those dimensions are there, how what would be the gap between the containers, they are taken together, and a proper lashing arrangement, they are to be tied, a proper lashing arrangement is to be provided. Same thing, so that becomes more critical when we talk about the containers over the deck or over the, I mean the containers exposed. The lashing of these containers, some lashing mechanism has to be there to keep them secured, because the vessel may roll, and above the hatch means they will experience more acceleration, because they are away from the point of center of gravity, right, and it is oscillating. So, there are cases of containers getting washed away, because you meet a real rough weather, so huge waves hitting the ship, so all this lash will not work. So, those are accidents, you can't help, containers get washed away. Taking this advantage, some even they, that is the other side of the picture, you unload it deep at sea and claim it has been washed away and claim insurance. This is the unfair thing. So there people are these days trying to track the container movement. Very interesting problem, tracking a container movement. Your container you are sending, sitting here, you want to track it where it is continuously out at the sea. How can you do that? GPS, fine. What GPS will do? Container will not hold a GPS there. So it's essentially through GPS you know the position of the ship, but how a say this particular container is yours, whether that particular container is getting offloaded at mid sea or really getting washed out by storm, or even at the port of destination it is sent and it is going somewhere else. So, there is something called RFID. You have heard about this? Huh?
Radio frequency identification.
So, some such technique people are trying to use with the help of satellite. You have your own RFID embedded in the container, which will keep sending signals to the satellite, from where again you retrieve and you know what is happening to your container. But well, this is not yet done that way, but probably that is one of the way to keep track, because these are also important. It becomes part of the thing. So, anyway, so that is how we see that this ro-ro ships, its specific features are that it is a multi-decker ship, longitudinally stiffened decks, the side shell are transversely stiffened. Another specific requirement is ventilation requirement, a stringent ventilation arrangement should be there.
So what are we doing for ventilation?
Ventilation, well, I mean, you will have to have a proper forced ventilation. That means ventilation ducting would be there in the entire cargo region. In other vessels, there is no arrangement of ventilation as such. There are very, in oil tankers, some kind of ventilation is there, but bulk carrier as such, no elaborate ventilation arrangement, but here it will be elaborate forced, mechanical forced ventilation to take the thing. And then, well, cargo loading, unloading, it's a closed ship, because there is no question of cargo hatch opening. So, there is not much problem of torsional strength. Loading, unloading through ramps, either side loading or front loading, and should have proper telltale arrangement such that to ensure they are perfectly closed. And then, well, though transverse bulkheads is one of the requirement, used to be that unobstructed movement of the cargo, but well, that is giving the problem. So, bulkheads with proper hydraulically operated watertight doors, huge doors to be provided in the bulkhead. Okay, so we stop here. We will take up oil tanker in the next class.